Here we go. Oh man, I made my screen not quite right. Anyway, let's talk about exponents. We're going to talk about with the product rule of exponents, and especially with expressions, especially with terms. But let's start with a quick review. 5 to the third power. Couple things. The 5 is called the base. Write that down so you know the terms. If you don't. You should know these by now, but if you don't, that's okay. Write it down. I thought I was going to write that all cool. I almost wrote exponents without the E. It would be exponents. But that would be weird, so I didn't. And I shouldn't have put the S there. It should be just exponent, because there's only one there. So, exponent. So the 3 is the exponent. Now, let's talk about how we do that one. What do we do? All right, so 5 times 5 times 5. So 5 times 5 times 5 equals?
125.
125. Good. Okay, so easy review stuff. All right? Not too hard. Now, quickly, when you have a fraction, say 1/2, still review, 1/2 to the fifth power, what do we do?
1/2.
Okay, 1/2 times 1/2 times 1/2 times 1/2 times 1/2. There's 3 of them, 5 of them mean, so that's 1, because 1 times 1 times 1 times 1, it's 1. 2 times 2 times 2 times 2 times 2 is 32.
32.
Okay, good. 4, 8, 16, 32. Okay, so 1/32. All right, so review still. All right, now when we do it, when we multiply variables, which should be reviewed because I know we've already covered it, but let's make sure our bases are good. The rule for variables with exponents is this. X to the m power, m represent a number, times x to the n power equals x to the m plus n. Because when you multiply variables with exponents, all you do is you add the exponents. So for example, x to the 5th times x to the 7th times x squared. All we need to do, according to the rule, is add the exponents. So when we do that, we get x to the, what do you think? What is that? 5 plus 7 plus 2. What?
No.
Close.
Nope.
You're
17.
17.
5 plus 7 is 12.
Oh, 14.
14. I was trying to get it out. Then you said 17 before I said it. You were one off either way at first. Before you said 17, but then you said 17, then I cut myself off, so I didn't say it. All right, so it's x to the 14th, because all we do is add the exponents. Okay, easy enough? So let's try another one. Just as easy. M to the 3rd times m squared times m to the 4th times m to the 6th times, oh sorry, me rewrite that, messed up, times n to the 6th times n to the 7th. Now, m and n are different, right? So we can't mix and match those. So this is m to the 3 plus 2 plus 4 and n to the 6 plus 7. So m to the 9th, n to the 13th. Now we're done. We can't mix and match the m and the n's because they're different, so that's how we write them. No mixing and no matching. Now it's traditional that you would put those in alphabetical order, and sometimes even by order of magnitude, which would mean the n would come first because that has a higher magnitude with 13th power. Let's try one more. All right. Are you ready for this one? Because sometimes problems can be worded in such a way that they confuse you. Back in 2006, because this is where the book takes me, book's newer than that, but back to 2006, the fastest supercomputer's performance topped out at about 1 p f l.
What's PF?
I'll tell you in a second.
Oh,
OPS. Topped out at that. 1 p f l o p s equals, just giving you information, 10 to the third t f l o p s. It's a measurement of speed. Now, I even wrote it down, but then I lost where I wrote it down, so that's not very useful to me. So I'll have to look it up, because I used to know this term, but I honestly couldn't tell you right this second what that was. I wrote it down, and then I lost the card that I wrote it down on. It's not very helpful, but it's a measurement of speed. It's pretty fast for 2006 standards. Go a lot faster now. We keep basically every 2 years, we double what we could do 2 years before in speed, and in size, we divide it by 2 every 2 years is basically how it ends up being. It's kind of weird how that turns out, but anyway, moving on. All right. Each T-flops, 1 T-flops, this is what the problem's telling us, equals 10 to the 12th. I'll look this up when we're done, because I can't remember what it is, and I had it written down because I couldn't remember that either. 10 to the 12th flops. All right, so that's a lot there. Find the number of flops. How many of these are in this? Okay? First off, what you need to know is the letters are there to confuse you. They don't matter. What matters is trying to figure out this into here. Okay? So that's why I wrote it all down. All right. So basically that's 10 to the third times 10 to the 12th. Because one of these, which is what we want to find, equals this. And one of these equals this. So we multiply these two, we'll figure out this. So what is 10 to the third times 10 to the 12th?
under the 15.
That's 10 to the 15th, right? All right, so 10 to the 15th, so 1 p-flops equals 10 to the 15th flops. That's all it is. Because all we had to do is multiply those two.
The data's complex and you read it because the flops were.
It's always confusing when you read it. It's a lot easier once you start writing it out. Break the problems down. What is the problem telling me? The problem told me that this equals that, and it said this equals that. How many of these are in here? All I did was write it out. Problems are a lot longer, but that's how algebra is. Break them down to their little pieces, and they ain't so bad.
So
Okay.
is it pronounced tip-flops and tip-flops?
They're acronyms.
But it's fun saying tip-flops.
All right, so let me stop this, and now look at